Hello everyone, welcome back yet again, and in today's video we'll be discussing about a new topic, and I think you'll enjoy this topic because you'll see why. So we'll be talking about the impact of units and scale of measurement on the regression results. Okay, so what happens if I change the units or the scale of measurement of the data that I'm using to run the regression model. Okay, so in here we'll be discussing this very simple question, which is what happens if the units of measurement of data are changed? What happens if the units of measurement of data are changed? So does it impact the results of the regression that we get, or the estimators that we get? So is there any change? Is there any change in the slope coefficient or your uh, intercept? Okay, beta 1 and beta 2. So what is the impact of the change of the units of measurement? So we'll be discussing about the changes in the units of measurement here, and we'll also see an example, and we'll see how this affects the regression results. Okay. So suppose we have to regress GPDI on GDP. So GPDI is basically your gross private domestic investment. So how is your GPDI changing as the level of GDP is increasing or decreasing? Okay, whatever variation is there in the GDP, there has to be some impact depending upon the beta true value that we get, okay, on the GPDI. So how is that impacted if if there's one person who expresses the data in billions of dollars? So we have two people, two researchers, first and second. So this person, this first researcher, is expressing the data of the GDP and the GPDI in billions of dollars, okay? And the other person is expressing the same data in millions of dollars. So we'll try to see how this changes the results that we get, okay? Like if it at all changes the results. So there might be no change. So we'll see that what happens, okay? So this is the question that we'll answer. Will the regression results be same? Okay. This question will be answering. So this is my normal regression equation, right? So let yi star. So I'm bringing in a new variable, which is yi star, which is equal to w1 into yi. Okay. So this yi star is a multiple of your yi, and the multiplying factor is wi. Similarly, w1, sorry, and similarly we have xi star, which is w2 xi. Okay, we'll see what is happening. So we have increased the scale here of yi by w1 and of xi by w2. So where w1 and w2 are constants which may or may not be equal. So w1 might be equal to w2 or it might not be equal to w2. So both the cases are possible. Okay. Right. So they are called scale factors. So you are changing the scale of yi by w1 and of xi by w2. So yi star and wi star, these terms are your rescaled yi and xi. Okay. Now we'll see this by an example. Okay. So now if xi and yi are expressed in billions of dollars. So supposingly my xi and yi are expressed in billions of dollars, and I want to express them in millions of dollars. Then my yi star becomes this thousands time yi, and xi star becomes 1,000 time xi. So I know that 1 billion is equal to 1,000,000,000. Okay, so I've changed both the scale and the units of measurement. So now here I'm measuring the units in millions. Uh, so I've changed the units from billions to millions, and the scale has also changed. So now my variables are being multiplied by a factor called that is 1,000. Okay, so in here your w1 is equal to W2, which is equal to 1000. Okay. So my new regression equation becomes yi star is equal to beta 1 hat star plus beta 2 hat star xi star plus ui hat star. Okay. Star because your ui hat now will also be in millions of dollars. Okay. Just because you have changed the y variable and the x variable also in your millions of dollars. So this is yi star is equal to w1 yi, xi star is equal to w2 xi, and ui star is equal to w1 ui hat. So just keep this in mind that your ui hat square, sorry, ui hat star is equal to w1 ui hat, w1. Okay. So because it is related to your yi star. So basically, it is the error. Okay, in the actual yi value. Okay, so how much far away is my actual yi value from the average yi value? Okay, that is being captured by your ui hat. Okay, so by whatever factor your yi is changing, by the same factor your ui will also change, or ui hat will also change. Okay, so the error term will mimic your yi term or yi variable. Okay, so that is why it is being also multiplied by wi, sorry, w1. Okay, I hope this is clear now. So this is my new regression equation. Okay, so I know from the previous videos, so these are the formulas to estimate these estimators. Okay, so we have done these formulas previously. We have some more formulas here, right? Variance of beta 2 hat, sigma hat square. So all these formulas were done previously for the normal regression model. So these are the formulas for your new regression with a different scale and units. Okay, so if you compare, nothing is changing in the formulas, just your beta 1 hat is being changed by beta 1 hat star, your y bar is changed by y bar hat star. Similarly, your other variables are also being replaced by the star variables. Okay, that is the scaled variables. This is true for all the formulas. So these formulas are important uh, because now you have a new regression. So related to that regression, you have a different set of formulas. So technically, there's nothing changing in terms of the formula, in terms of the memory that you have to create in your mind for the formulas, because they're almost the same. So you won't have any issues. But we don't need the proof of these formulas. I just need you to see a comparison how the formulas have transformed as the regression equation has transformed. Okay. Similarly, in here for these formulas, uh, so your normal variables are being replaced by your scaled variables. So that is what is happening. Okay, there's no uh, significant change. Okay, nothing new is being added to the formula, or nothing existing is being dropped. Okay, the formulas are almost the same, just the star variables are are replacing the normal variables. So the important thing here is, so how is your beta 2 hat square or the new variables related to the previous unscaled variables, okay, in terms of your scale factors? So these are the formulas. So these formulas you'll have to remember. Okay, 2, 3, 4, 5, and this 6. So if you see, your beta 2 hat star is basically equal to W1 upon W2, a ratio of the scale factors into the previous beta 2 hat value. And your beta 1 hat star is equal to W1 into beta 1 hat star. So your beta 1 or the new intercept term is basically a function of the previous intercept term and multiplied by a factor W1. So there is no rule of W2 here. Okay. Similarly, your sigma hat square is basically equal to W1 square into sigma hat square. So a extra factor of W1 square is coming. Okay. That is how your new sigma hat star square is being transformed. Similarly for other terms. Okay. So what this means, okay, what these changes mean, the r square terms, you can see the relation. So r square xy is equal to r square x star y star. Okay. So these are the changes, or these are the relations between your previous estimator and the new estimators in the scaled regression equation. So the significance of this is that if W1 is equal to W2, so these questions can be asked. So these formula become important. So if I see from here, if W1 is equal to W2, then your beta 2 hat star is equal to beta 2 hat. Okay. So this implies that the slope coefficient, that is beta 2 hat and beta 2 hat star, and its standard error remain unaffected in going from the normal variables to the scaled variables. Okay, so if W1 is equal to W2, there is no change in the slope coefficients or its standard errors. Okay, but the intercept and its standard error are multiplied by W1. So you can check this from the formula. So this intercept term in the new regression equation is a function of W1. So it will change even if W1 is equal to W2. Okay, because beta 2 is a function of beta 2 hat star is a function of W1 upon W2. Okay, that is why this is not changing, but this will change. Okay, your intercept term will change, but your slope coefficient will not change if W1 is equal to W2. Similarly, if x is same, so if W2 is equal to 1 and y is changed by W1 factor. Okay, the slope as well as intercept coefficients and the respective standard errors are all multiplied by the same W1 factors. So if I just change W1, okay, and W2 is equal to W2 is not is equal to 1. Okay, there is no change in the x factor or the x variable. Okay, there is no scaling or change of unit in the x variable. So my all my estimators, okay, they will change by a factor of W1. Okay, if you see, if W2 is equal to 1, it means that your new beta 2 hat star is equal to W1 into the previous beta 2 hat. Similarly, this goes for everyone, every of these formula. Okay, now, and if I only change the x variable or the scale of the x variable by a factor of W2 and the y remains unchanged, then all of these formulas, not all, uh, your beta 2 hat star, okay, or the slope coefficients and the related formulas uh, will change by a factor of 1 upon W2, while your intercept intercept terms will remain unchanged because your intercept, as you can see, is a function of W1 and not W2. It has no relation with W2. So these are the practical uses of these formulas, and this is how questions can also be created. Okay, if uh, suppose in a scaled regression equation, the scale factors are W1 and W2, and if you change the scale of only one of the variables, how would the estimators or the of the new parameters will change? So these are the kind of things that you need to remember, because questions can be created in this form. I hope you understood. I hope you found this interesting. Okay, so I'll see you in the next video soon. Till then, take care.